be a quick unit. Unit 5 is about quadrilaterals. And the biggest thing in our quadrilateral unit is going to be parallelograms. So today we get to talk about what makes a parallelogram a parallelogram. Tomorrow we'll prove parallelograms are parallelograms. Then we'll talk about rectangles and rhombi and squares, take-home quiz. We'll come back, we'll cover trapezoids and kites, and take a test. First off, what is a parallelogram? Well, simply stated, a parallelogram is a quadrilateral where opposite sides are parallel. Makes it a parallelogram. But there's a couple of other important properties. So if a figure is a parallelogram, opposite sides are congruent. They're not necessarily congruent to each other, but so like all four sides are congruent, unless we start talking about rhombi and squares. But in a parallelogram, opposite sides are congruent. In a parallelogram, opposite angles are congruent. So the vertices across from each other are congruent. Consecutive angles, meaning they share a side. Consecutive angles are supplementary. What's it mean to be supplementary? There's sum equals 180. And the last characteristic of a parallelogram is that the diagonals, lines connecting opposite vertices, the diagonals bisect each other. And what's it mean to bisect? Cut in half. The diagonals themselves aren't necessarily congruent, but we do know that when they intersect, it's going to cut them into two congruent sections. Number 2, we're going to find the missing side measures using the properties of our parallelogram. For JK, what do we know about opposite sides in a parallelogram? Opposite sides are congruent. So if ML is 21, then JK is 21. How about KL? What do we know about opposite sides in a parallelogram? They are congruent. So if JM is 29, then KL is 29. It's not too bad at all. Parallelograms are pretty lit. Angle J. What do we know about opposite angles of a parallelogram? Opposite angles are always congruent. Well, J is opposite of L, and if L is 127, then J has to be 127. So this is where we got to do a little bit of math. We can't just write stuff down, unfortunately, no more. Angle K. In a parallelogram, consecutive angles are supplementary. So J plus K equals 180. Or I could have done K and L. It doesn't matter. It just matters that consecutive angles are supplementary. So the measure of K, well, that was an ugly. Measure of angle K plus 127 equals 180. Subtract 127 from both sides, so K is. Now that we found K, what is M? How come? Opposite angles are congruent. So we know M must be 53. Now, K and L should be supplementary. M and L should be supplementary. J and M should be supplementary. And J and K should be supplementary. Consecutive angles are supplementary. Opposite angles are congruent. That's about as tricky as this is going to get, is trying to mess with you in angles. Not too bad, right? So let's have some more fun. So it says XY is 15. So that's this side, 15. WX is 22. ZX is 32. So that's this full diagonal here. And then WT is 10. WZY is 62. WXT is 27. And ZWT is 77. So we got a lot of missing pieces. What's that? It looks complex. Well, what's going to happen is a lot of these numbers are going to end up being the same. All right, ZW. Who is ZW congruent to? XY. Opposite sides are always congruent, so ZW is 15. Look at that. First one done. What about ZY? It's congruent to WX. Opposite sides are always congruent, so it's 22. Sir. Yeah, I do that. It happens. What about TX? TX. What do we know the full length of ZX to be? 32. And what do we know happened to ZX because this is a parallelogram? It was bisected, which means cut in half. So if we divide 32 in half, TX is 16. So that is 32 over 2. Because it bisected that full diagonal. How about WY? What piece of information did they give me involving WY? Why? Yes, sir. Okay, so how is WT being 10 relate to WY? Because it's bisected. Yeah, so we just do 10 times 2. So WY is 20. Diagonals are bisected. Now we got all these angles we got to deal with. That's a lot of angles. TZY. What did I tell you guys about parallel lines and always being able to look for a what? Alternate interior angles. So TZY would be this angle here, correct? Yes? Well, this side's parallel to this side, cut by a transversal. So what do we know about these two angles? They are congruent because of alternate interior angles. So TZY is 27. XYZ. So remember, we just follow our vertices, X, Y, Z. So we want this full angle here. What do we know about consecutive angles in a parallelogram? Consecutive angles are supplementary. So that means Z plus Y should equal what? 180, great answer. What? 32? I don't think so. So we know 62 plus, what did they say, XYZ? XYZ equals 180. Subtract 180 from both sides, or 62 from both sides. The measure of XYZ is, survey says, 118. Hooray. XWT. Ho, ho, ho. Another new way to find angles. So if Y is 118, what is the full measure of W? Y. Opposite angles are congruent. So if Y is 118, W is 118. What else do we know about that angle? What else has happened to that angle? The angle's not bisected in a parallelogram, but it is being intersected by that diagonal. And if 77, so this full angle measures what? 118. And the angle sum theorem tells us that when we add two angles together, zoom out, zoom in. So to find XWT, we're going to add 77 and set it equal to what? What do you think? How come? Right, that full measures 118. We know a piece of it is 77. So we subtract 77 from both sides. So what's XWT? 41. Is it right? Okay. And then our last one is XYT. Looks like we get to go back to R. So XYT, this guy right here. What do we know is true about parallel lines cut by a transversal? Oh, that's the wrong transversal, isn't it? Parallel lines. It's just the wrong set of parallel lines. Transversal. Alternate interior angles are always congruent. So 77. Find YZ. What do we know is true about parallelograms? They are parallel, which means that their opposite sides are and congruent. So because this is a parallelogram, my opposite sides are congruent. And if my opposite sides are congruent, what can I do to allow me to solve for x? Set them equal to each other. Absolutely. Root-a-tootly. Root-a-doo-doo-doo. My little box gets up there. So we've got 11x plus 1 equals 19x minus 31. We know those sides are congruent, so they must be equal to one another. And now we just get to solve for x. So we subtract 11x from both sides and add 31 to both sides. What's wrong? So we get 32 equals 8x. Divide both sides by 8. X is 4. Are we done? No. What do we got to find? We got to plug in 4 for x so we can find the length of YZ. You could do WX if you wanted. It's up to you. But what allows you to do WX? Because they're both congruent. Absolutely. But I'm going to stick with 4 because it's down here already. 19 times 4 is 76. 76 minus 31 is 45. Hooray! Huzzah! NS is 2x plus 7. And SQ is 5x minus 23. Find the length of NQ. So they want this whole length. Well, what do we know about the two values they gave us? What happened? What did PR do to NQ because this is a parallelogram? It bisected it. When it bisects it, it cuts it in half. So what do we know is true about NS and QS? They are congruent. So because they're congruent, what can we do as brilliant mathematicians? Set them equal to one another. 5x minus 23 equals 2x plus 7. And then another basic algebra problem. Subtract 2x. Subtract 2x. Add 23. Add 23. So 3x equals 30. Divide both sides by 3. What's wrong? Oh, x equals 10. Good. But that's not what they wanted, is it? No. They wanted the full length of NQ. So do I need to plug 10 into both of these? Just one, and then multiply by 2. So let's go 2 times 10 plus 7. 20 plus 7 gives me 27. So that means the length of NS is 27. So what would the full length of NQ be? (27 times 2), which is 54. Absolutely. But the algebraic equations don't just apply to sides or diagonals. We can also use them to help us solve for angles. Find the measure of R. Man, them slippery rascals. But they gave us Q and P. What do we know is true about consecutive angles in a parallelogram? They are supplementary, which means what? The measure of Q plus the measure of P equals 180. That is true. And even if we looked at this using our Unit 2 brains, what do we know is true about angles that are both inside the parallel lines and on the same side of the transversal? What do we call those? Yeah, same side interior. Or they called them consecutive interior angles. Dun, dun, dun. So it's the same rule we already know. So 8x minus 12 plus 3x plus 5. Somebody asked me last class, how come they put parentheses around them? It's just so you don't lose anybody in the transition. You don't want to lose numbers. So we combine like terms. So we got 8x and 3x, negative 12 and 5. So 11x minus 7, equals 180. Is that right? Add 7. 11x equals 187. Hopefully that's divisible by 11. 17. X equals 17. So they wanted R. Now we could go through that whole supplementary process again, or we can substitute X in for P. What would be the advantage of putting X into P over Q? What do we know is true about angle P and angle R? They're congruent because in parallelograms, opposite angles are congruent. So we can just substitute that 11 into P. So 3 times 11 is 33, or 17. Where, you dummy. 17. 3 times 17 is 52. 51. And then 51 plus 5 is 56. So if P is 56, R must be R equals P. So the measure of R equals 56. This last guy looks exciting. All right, our last guy. So we got to do some moving, some shaking. We gotta refry some bacon. It told us that the full length of angle ABC is 115. But it put this angle down there. Oh, man. What'd they do that for? Can we manipulate this problem to help us solve it? Well, parallel side, transversal. What do we know about those pieces? They will be congruent. So because those two angles are congruent, based on my alternate interior angle theorem, I can take that 6x minus 11 and just move it up there. So we just had to do a little manipulating before we started calculating. Now what do we know is true about those two angles? Their sum equals 115. So 4x plus 6 plus 6x minus 11 equals 115. Combine like terms. You stupid thing. So 10x minus 5 equals 115. Did I do that right? 6 minus 11 is 5. Maybe. Could be 23. It could be. 10x equals 120. Divide both sides by 10. So x equals 12. Now the question is, which angle did it want? A, D, B. So remember, we just track along our vertices, A, D, B. So it wants this guy right here. So what are we going to do with that 12? We're just going to plug it back in. 6 times 12 minus 11. 6 and 12 is what, Brock? Yeah. 72. 72 minus 11 is 61.